speakers, you have 5 minutes. When you get down to 1 minute, I believe Karen is going to put her hand up to just let you know, hey, there's 1 minute left. When you get to 10 seconds, Karen is going to start the slow clap. So everyone's going to start doing the golf clap. And then at time, we're going to clap and cheer very loudly because we're so excited that you did a 5-minute lightning talk. But of course, everyone's going to finish right on time. And with that, let's just jump into it because you don't want to hear me. You want to hear the lightning talks.
Thank you very much. Okay, right. I have my timer there. Well, I don't need to be on stage for this bit, do I? Okay. Right. Here's where we find out, do we have the lightning talks in the correct order? So the first lightning talk speaker should be Grant Zhou, Connecting the World with Open Source.
This is what we do?
That's not the first slide.
Oh. Oh, so I gave away the punchline.
Okay.
Right.
Are we just doing clicking on there?
Okay. Time started?
Timer. No, because I'm incompetent, so you've got extra time.
Okay. Okay, thank you for having this such an exciting conference I ever attend. Thank you for the organizers for the great work. Today I want to give you a short talk about connecting the world with open source. And I'm Grant, and I'll give you a short, well, my name is Grant Zhou, and I have a strong passion for PostgreSQL. I think most of the people here ever saw me before, and I hope to see you every year then. But I work for Haysler Software. It's a company with a long-standing involvement of PostgreSQL world. And I live in Vancouver since 2013. And next year for the SIP conference, I will see the guys there. And I'm a firm believer in the impactful nature of open source technology. And this photo, actually, it is just a photo that yesterday I took with Melanie, Cedric, and myself. Okay, the PostgreSQL magic. So it is an amazing project. It has, well, I don't know whether you guys count it or not, but I didn't. It is just 100 possible contributors, countries, sources, and it is a community that strangers can become collaborators and no argues about who buys pizza. Okay, and one shared goal is we are going to make a great, amazing PostgreSQL database. And we are all here right now, and despite conflicts and tensions, regardless, whatever happens on the world, we are all here for the one same thing, discussing the PostgreSQL together. So that's the spirit of the open source. And what really actually united us is, we are discussing the shared frustrations with slow queries, with the heated debates about multi-thread on PostgreSQL, and the excitement over new features like AIO, and the extension wars like which one makes PG amazing, right? And code that transcends all borders. That's the thing that unites us together here, and that's also we love PostgreSQL a lot. And another chance then. The open source united everything and united the world, and still there is another chance for you guys to join together. Is the conference happens in next month, and which is in Jinan City. I hope looking forward to have some guys there. And it will focus on the PostgreSQL and the ReluctantUsers, which database will have the Oracle compatible features. And it is available for both in-person and virtual participation and engaging with the global community. And we want to use the conference to link in the world, with the open source. It happens in Jinan, and this URL, reluctantUsers is the official website of this conference. I'm looking forward to see you guys there. And if still have time, actually, there is a, can I open that? Yep. No.
1.5 minutes to go.
Okay, it is kind of a video, and I hope it is also for this conference. And no voice, that's okay. But still, the reluctantUsers website has this video, and if you guys have a chance, take a look at that. And thank you very much.
Thank you. I might need an assistant. I haven't got enough hands. Okay, next up we've got David with Teaching Elephants to Tell Time. I'm not pressing anything. I'm going to just hand the...
I'll take a mic.
Oh, that's a good point. Where did the slides go? Where did you put the slides? There they are. Okay. No. Help. It was there. I don't know where it went. How many technicians does it take?
I hope you
display a
enjoyed the talk.
PDF?
And all right, here we go.
An extra hand would be
All right, hey, so I'm David from Amazon, and this is a 2-hour talk condensed to a 50-minute talk condensed to a 5-minute talk. So this is about adventures in distributed snapshot isolation, a very simple topic. So it's kind of a complicated topic, and this is the foundation for Aurora Limitless Database. This is what the fancy architecture picture looks like. Lots of boxes, complicated stuff, but really it's a familiar pattern you can create into a couple boxes. So Postgres server, shards, FDWs, right? Like everyone here knows this pattern, but this pattern has some problems. So Postgres and FDWs cannot provide snapshot isolation across all these shards. And so that is because Postgres creates snapshots as of now, the moment you tried to create the snapshot, and it builds these snapshots using lots of local state that it serializes about what's going on in the system. Grabs that proc array lock, goes through, figures out who's running transactions, creates exclusion lists, and all this fun stuff, and that really doesn't work well in a distributed system. So let's think about that. So let's select the balance, the sum of all the balances in pgbench accounts. We'll assume this is sharded across the system. So the query hits the first node, it creates a snapshot right now. All right, and it looks at what other transactions are running on that node to see what should and shouldn't be included. Then it's going to forward that query down at some point to, say, shard 2. And shard 2 will create a snapshot like right now based on what transactions are running on shard 2. And, you know, even if you sent these all at the same time to the shards, they all arrive at some other time, and everyone creates their own snapshot with their own idea of what time it is and who's running and whatnot. And you don't get a consistent snapshot. You don't get snapshot isolation. So what we did is we said, screw creating snapshots as of now. Let's create them as of then, right? As of some point in time, and let's not worry about any local state in the system. Cool. All right, so that's time-based MVCC, which is a spin on, you know, Postgres communities talked a lot about commit sequence numbers, commit timestamps, whatever. This is our implementation of time-based MVCC. So simple building blocks. You want to create a snapshot. Your snapshot is just the time. You don't really use get snapshot data. That thing uses a lot of CPU. Community's done an awesome job optimizing it over the years. I think Andres has done a lot of work there. Still, don't need it anymore. Irrelevant. All right. Pass that snapshot time along to the shards when you send down the query fragment. So say not only give me the sum of your part of pgbench accounts, but give it to me as of the time that I use for my snapshot. So everyone can use the same time. Record commit times in the C-log itself. Oh God, this 2-bit C-log is now this big 64-bit entry. But yeah, you get atomic commit times in the C-log, and then you just do visibility, and this is all simplified still a little bit. You do visibility based on the commit time versus snapshot time. All right, none of all this looking at running transactions list. Simply, I know the time of my snapshot. I see the transactions committed, what is its commit time. If it is before me, I can see that transaction. All right. So this now, you may be going, wait, hold on. These are a bunch of different computers with a bunch of different clocks that everyone has a different idea of time. Everyone in this room's watch has a different time, even though they're all synced up, right? So we use something called Clockbound, which is an open source piece of software from AWS. And it helps us determine the error bounds on the current clock. So each system has its own idea of time, but it also kind of knows how far off its clock could be earlier than later. I don't know what time it is right now, but it's like after 4 and before 6. Like, that's probably, we can all agree on that. This system does it, but it can shrink that down to millisecond or microsecond error bounds. There's all sorts of cool clock stuff in here this is why it's a 2-hour talk that I won't talk about because it's a 5-minute talk. All right, pseudo commit algorithm. Normally when we commit, we wait for transaction durability to commit. Here we wait for transaction durability and for clock error bounds to resolve. Cool thing is you do that in parallel. So even when we are 60 shards doing 2 million commits per second, we actually don't do any waits here. It works perfectly. Skipped a bunch of things I didn't talk about. Distributed transaction coordinator, long fork, and we will propose a talk tomorrow. Thank you.
Perfect timing. Absolutely perfect. Well done. Okay. Next up, we have Akash with hardware acceleration and SIMD optimizations in Postgres. In theory, they should all be in the same deck, so it should just be advance the slide. I like the collaboration, though. We have second-level support here if needed. We're all right. Okay, stage is yours.
Thank you. Hi, everyone. My name is Akash Shankaran. I am here from Intel. This is also my first PGConf, so thank you to the organizers for organizing such a wonderful event. And also for the lightning talks, for giving us a chance to present about our topic. Oh, it's, hold on. Sorry. So I want to talk about some contributions that Intel has done in the past and upcoming things and just open up an idea for feedback. So Intel has been contributing for about 2 years to Postgres. We added pop count optimization using AVX512, which improves bit count. It also resulted in improvements to binary vectors. For PG vector, there was a talk earlier which highlighted some SIMD acceleration. Then we added optimizations for CRC32C. And a big thanks to the maintainers and the committers who accepted our changes and helped us merge it in. So what are we doing now? SIMD is a pretty relevant topic, and it's giving databases a good amount of speed up. So here's a list of some things that we are currently looking at. Checksum improvements. There's one for improvements to high core count systems. Then the topic which I want to go in a little bit more detail today is on sort, where we want to bring in a library called x86 SIMD sort, which improves tuple sort and list sort performance. List sort benefits PG vector, and there was a talk earlier about how PG vector is relevant. So what is the proposal here? The x86 SIMD sort library, it's a well-known library. It's going to optimize sorting, and it uses SIMD intrinsic. So on machines that have AVX2, it'll use AVX2. Where it's AVX512, it'll use that. The way we want to implement it is by extending the templates. So today's sort in Postgres is implemented as templates, and we want to create a new template for the new sort we want to add. And in the next slides, you'll see some results that we have seen, very initial results on tuple sort and list sort. Before the results, just want an overview of the library. It's already used in some major ecosystems like NumPy, JDK. It's under consideration by PyTorch as well. It's open source, as Postgres expects a lot of dependencies to be. We want it to be an optional dependency as we build it. From the library, we want to use quicksort as one of the techniques. And we want to use the numerical portions initially. So this is the brief results that we have observed on tuple sort. So you can see for different number of rows, 100K rows with number of different distinct values, which is the cardinality. We can see some level of gains. On higher cardinalities, we do observe some negative numbers, and we are working on addressing that. There are two data sets that we tested. This was a small test that we did initially. Similarly, same library on list sort, we saw about 7% reduction on index build times and 10% in another data set. This was on vector search. Having the same library as a core dependency we felt would be a good approach. It can solve two sort problems with one change. On the same idea, we are open for additional feedback. I'd love to talk to you if this is a topic of interest to you. Also want to understand more parameters beyond, essentially beyond cardinality, what else would be of interest. And essentially any other ways of adding SIMD-based sorting, like if we want to do it earlier in query execution or during query planning stages. I'm open for those discussions. If you have any thoughts on this topic, feel free to find me after the talk. Or any other SIMD ideas, I'm here. Thank you.
Thank you very much. Awesome. Okay, next up, James talking about setting up logical replication with PG init subscriber. Or not.
Yeah,
Okay.
there's no name. Yeah, I'm James Miller. I think this is my first slide. There might be one before this, though. How do I go back if I should check? I'm going to talk about setting up logical replication. There's lots of reasons you might want it, but the quick and easy way to set it up is with all tables. But if you have like a schema versioning table, it can cause issues because you either get to run your migration on the thing and then delete it out of the change log, then run it on the primary, or you run it without your schema deployment tool, which is not why you're using the schema deployment tool. So all tables can be, kind of, it would be handy to not replicate like schema version tables from Liquibase or Flyway or anything like that. So you can manually list tables, but if you have a lot of them, that's not very fun. So we made a script I made a script to make setting up stuff easier with the all tables style of logical replication. If your creds are everywhere and you're using the Postgres user, probably I should have used the user that's running it, but I didn't. You can just specify the host, the database name, and the target host, and it will create the database over there and migrate the schema and create a logical replica using per table. If you want to migrate roles too, you can throw in a -L and it'll do a PG dump all and throw the roles over. That doesn't work in Amazon land because you don't have access to PG Shadow, so there's a big L version that dumps roles without passwords. And the W, when you're creating your subscription, normally you have to put in, like if you can have things like in your PG pass on your subscriber node to connect to the publisher node. Obviously you can't do that in Amazon. So the W flag will actually pull your creds out of whatever the active PG pass is and actually include those creds in your subscription. And if you're using things like search path, you can throw in a -G to migrate search path, time zone, other alter DB settings, though I've tested search path and time zone. anything else is, you're testing it. The tables can also be omitted with the -t flag to drop out the changelog table if you want to do that. And that's it.
Well, this is no fun at all if we don't get to chase anyone off the stage. Now I have to reset my timer. Okay, so Ikeda-san, is that?
Yes.
With my first patch, adding new option to PG Bench. Right, let me sort my timer. Okay, the stage is yours.
Hi, I'm Rintaro Ikeda from NTT Data Japan. I'll talk about my first patch, which is still work in progress, and which is adding a new option to PG Bench. Yeah. Also, I introduce myself. I'm probably the least experienced with PostgreSQL in this room. Yeah, I started using PostgreSQL in 2023, and I began reading Postgres source code in 2024. And last week, I submitted my first patch modifying source code. Thank you. And this is the title of the mail I submitted to hackers mailing list. Suggestion to add continue client on abort option to PG Bench. I'm addressing an issue related to PG Bench. Yeah. Here is the issue I aim to solve. Currently, a client of PG Bench stops sending requests when its transaction is aborted due to reasons other than serialization failures or deadlocks. Here is an example. Yeah, my custom script of PG Bench is to create table, if not exist, which second column has unique constraint, and insert a random value into the table. I try to execute PG Bench with custom script for 10 seconds, but PG Bench stops in a second due to violation of constraint of unique constraint of the second column. Yeah, that is because a client stops sending request when its transaction is failed. Yeah. This issue may result in a lower server load than we expected, especially when you specify the number of clients or duration time. So I proposed a new option, continue client on error. If you specify this option to true, when transaction fails, client roll back the failed transaction and start new one. And the number of clients remains unchanged even if the transaction failed. This is the example. I execute PG Bench with the new option for 10 seconds. The custom script is the same as the previous slide. Then all clients keep alive for the specified time. In this example, PG Bench keeps applying load for 10 seconds. Yeah, that is the explanation of my patch. Yeah, I'm still working on it. If you are interested, give me feedback. Thank you.
Thank you so much. Okay. Next up, Stacey Haysler. Starting with Postgres, how to become part of this incredible community.
Hello, everybody. I'm Stacey Haysler. This is my lightning talk. It's my first lightning talk, by the way, in 15 years of coming. I am finally doing a lightning talk. So, according to PostgreSQL.org, we have 700 plus contributors out of millions of happy users. You too can be a contributor. There are so many opportunities, and we're going to look at many of them. First, I had to update this meme because, yes, the penguin would like to Postgres. You, however, do not have to be a penguin and do not have to go to the Antarctic in order to Postgres. So, starting alphabetically, advocacy. Many things that start with C, D, E, and H. I/O, international organizations, not just input-output. The PostgreSQL alphabet soup. I mean, the PostgreSQL nonprofits. Postgres Women and Postgres Women India. Watch them. They are doing amazing things. Thank you, Karan, Brahmani, and Arti, and Praveen for doing that amazing work. Things that start with S, including our sysadmins, for whom we are very, very grateful that they keep all of this going. T, U, W, the Xylophone Marching Corps, the Yodeling Team, and the Xenia Growers. Okay, X, Y, and Z don't really exist, but I just had to get to Z. So, you think, I haven't been in the Postgres community very long, I don't know a lot. I think Ikeda-san just kind of proved that you don't have to be around a long time or have worked with it a long time to contribute meaningfully. But I would like to point out that these two guys, everybody knows them, everybody knows their names, but once upon a time, they were new too. You can go to this wiki page, find out all the amazing opportunities available to you, and pounce on the one that seems most interesting. Thank you. And those are Xenias.
Thank you, Stacey. That was amazing. Okay. Lukas Fittl next with shared blocks hit distinct and how we can make it work.
All right. This is on. Wonderful. All right. Am I good to go?
Let's go.
Cool. All right. Shared blocks hit distinct. What do I mean by that? Well, basically the problem is if you know shared blocks counters and explain or any of these stats tables, it double counts, right? So shared blocks hit counts page accesses, buffer page accesses, not the unique pages you're actually looking at. So let me give you an example more specifically of what I mean. We took two tables. I took two tables earlier today, inserted a bunch of data, I created a bunch of indexes, and then I made myself a little query plan that, thanks to the Postgres 18 change that makes buffers by default, we now see the buffer accesses here by default. So in this plan, we see a nested loop, getting data from one index, and then basically doing point lookups on the other index for each of those values. Now, the important number that I care about here is it says shared hit 13,500. You might think that that means you looked at 13,500 8 kilobyte pages, which if you looked at the number of data that I inserted into the table is a multiple of the size of those tables, right? This is a problem for lots of users of Postgres. People run explain analyze now with buffers enabled by default, and they think that this index-only scan looked at a lot of data, worked with a lot of data, which is not true. So if I restart Postgres, I can see the read counter, and you actually see that this was only 13 pages that were actually read, right? That's 1,000 times difference between the pages hit and the pages read. Now, what if we could do this better and we could tell people how many pages we actually looked at uniquely? Now, if we did this with all the IDs, right, and we remembered all the pages we looked at, that's too expensive. But we have an existing in-core solution for this with HLL, so we can actually count and like have a sketch logic basically for counting roughly how many unique distinct values we can see. And we have a global struct today called PG buffer usage that tracks buffer usage counts. Now, unfortunately, this is a cumulative struct, meaning each time we encounter a page that's being hit, we increment that counter. And then if you've done benchmarks before, you probably know that some of that has a little bit of overhead because, especially in the instrument instr-start node and instr-stop node, we do a lot of diffing because the way this works today is we keep counting up and then when we report it, we do a bunch of subtractions, right? That's actually not great. Now I have an idea how to do this better. As you might see, this is a diff where buffer usage accum diff is removed because we no longer need it. Because there's two things I think we should do. First of all, I think we should use a stack in instr-start node, instr-stop node that would allow us to basically be more performant. But second, if we use a stack that basically says, this is a struct for what was done, not in all time, but just in the last period, then we can add an HLL struct optionally, and this HLL struct lets us count distinct buffer hits. What this lets us do, by adding a special buffers distinct option, is we can say, as an estimate, how many buffers we actually found uniquely, right? This would be intended not to run all the time, but if you're benchmarking and you don't want to restart your Postgres server and you want to know how much data did it look at, you can say, roughly, we looked at 16 pages. Now, the correct number is 13, right? So this is directionally correct, but not the exact number. But turns out, in a lot of times, this is what you want to know, is how much data did I roughly look at? So I have a patch. This works. I have it on my GitHub, not in Hackers yet, because it's kind of messy. My intent is to post this in Hackers in a cleaned up version the next couple of weeks for the 19 cycle. But if you want to talk about this kind of stuff, I'd love to talk to you tomorrow at the Dian conference. Thank you.
Thank you very much. Okay. Next, Dian Fei, results visualization with the second best Postgres RePl.
Okay, I'm Dian. I write a lot of strange tools, and I'm not going to give Karen time to get started. So RePl comes to us from Lisp machines originally, the read, evaluate, print loop, where you interact with something very much like PSQL. And speaking of, say, second best, what is the best? No surprises, it is PSQL. But please, if you use it and do not use PSPG, do yourself a favor. Pavel has saved me probably weeks to months of cumulative drudgery. Cannot recommend that tool highly enough. It really does make it the best. But why settle for second? And you settle for second when you have some specialized thing that you need to glue together, which you do with the shell. So this obviously is that. It lets us sort of get as computery as it gets interacting with the machine. And I have been putting this to some strange purposes. I have a poster out by the registration desk talking about one of these tools, but I have a few other very specific things that I'm going to show off real quick. I have done some geospatial work, and something that bugs me is it's very, very difficult to do geospatial stuff without actually looking at the results of your query. And I don't like clicking, so I don't like geospatial viewers. I do like typing. So I have a tool that can take a script like this, run it, and produce output. So this is not actually Canada. It is all of the bodies of water and streams and rivers in Canada, but it looks a lot like Canada. This also takes a hot minute to run because it is all of the bodies of water in Canada getting union together. So let's set up a bounding box around this to try to get more specific. That kind of helped. But this tool, PGISD, can also take in xmin, ymin, xmin, xmax, ymax. And now you can actually see the like Huron over there, St. Lawrence Seaway. That's much more useful. And you can move and pan around with different X's and Y's. Geospatial data comes in two flavors. The other is rasters. We can do something similar. Here is elevation. So that's it for geospatial. I have a third case that I have adapted this technique for to invoke GNU-plot. So this is a query from the old version of this. Please ignore the different latitude, longitude coordinates. We can just call it GNU-plot, dump it into the terminal. It is 2025. Terminal emulators can display images if you're not using a Relic VT100. I use WesTerm, iTerm2, Kitty, Console with a K, all support it. So this is a very versatile technique. There's no files involved. This just gets piped directly to standard output. We can also use time axes in GNU-plot. And I have no idea what's coming next. Thank you.
Thank you very much, Dian. Okay, next up, Chioma with feature engineering with SQL.
Start. Hello, everyone. I'm Ruohung Feng, distribution maker and the author of Pigsty. Today, I'm going to give a very lightning speech. Well, I'm talking about extension delivery. So, last year I wrote a blog post, Postgres is eating the database world through extensions. We have a lot of extensions. If we look into the ecosystem, we have a competition on vectors. We even have a championship for putting DuckDB into PostgreSQL and Attentive too. We even have crazy stuff like extension which makes PostgreSQL speak the language of MySQL, SQL Server, MongoDB, and Oracle. Yet, every week I have been asked by users, cool stuff, but where can I get the packages? Well, extensions is useless if they are not accessible to users. So the reality is developers like developing things, but what they provide is a repo and source code. But what the users want is create extensions and start using. So I have built 3 things open sourced that fill in that gap, which makes developers' work more accessible to the users. The first thing is an extension catalog. It has 440 extensions so far. It's a handwork. I scrub almost every public source finding extensions and put them into this catalog. What is catalog? It's essentially a CSV file which contains all the necessary information that you need to know about extensions. Did it need DDL? Does it need preload, relocation, or trusted dependencies? Works on which PG major version, etc., etc. It also has a web version which is more human readable. Besides, we also collect the deb RPM metadata so that you can check the availability on different OS distributions and download them easily. And these extensions are categorized like into 16 categories. We have extensions for time, extensions for geospatial, for vector embedding an RAG. We have extension for text search, OLAP with DuckDB, or play with programming languages, or using custom data types, access foreign data with wrappers, or we can have some feature and utility extensions, administration and observability, security, simulation, and ETL replication. All those extensions are categorized into this catalog. Yeah, here are some statistic numbers about the repo. We have PGDG repo and the additional PigSty repo, which I think the number will grow in the next year too. The second, okay, so that is our hand job in the past year. And yeah, with this catalog, the users really can access the information they need to evaluate the extension. But what's more important is how do they install and download. So the second bridge is a supplementary extension repo, which works in addition to the official PGDG repo, which is available on 10 mainstream Linux distributions. It's very easy to use, just add the lines and it will work. Well, it's easy to use, but hard to maintain. We have encountered some challenges, like the possible combinations is exploding, Rust extensions are coming, and shipping them is quite tricky. We have some extensions that is really big, and some extensions only works on folks. Some extensions are competing for names, and some extensions competing for libraries. Some extensions are just not maintained, and some extensions are retired and obsolete. But that's okay. I'm going to handle these issues, tedious work for extensions developers, and I will deliver these extensions to the users. Yeah, and one more thing is the package manager pig, which piggyback on the OS package manager. Well, you can just install with one line of code, and it's easy to install. You can install different versions of Postgres and extensions. Well, you can manage repos. You can even build the extension with it in a single line of code. Yeah, we also have answers for other problems like provisioning all the stuff, download, install, load, configure them all, but that's another story. Finally, in summary, make your extension more accessible to Linux or Postgres users. And I think this can, I hope my work will benefit the community. Thank you.
Absolutely perfect. I think you had 1 second left there. Okay, next. Oh, yes, it is. Alastair Turner with the Reluctant User and Underserved Community.
Good afternoon. I'm feeling under a little bit of pressure here. I don't want to be the one person who gives Karen her fun of chasing people off the stage at the end. I've recently taken on a community developer relations role at Bacona. And before that, I did pre-sales. And the idea behind this talk was trying to bring together the idea of what community is, what it consists of, and some of the stuff that I used to bump into in pre-sales in trying to get users happy with Postgres. So we start off with a few ideas of what community is. The first is people who build. This is a reaction a lot of people have about what a community is. And this isn't just the code. It's the events, it's the building of the community that builds, all the rest of that. For the sake of brevity, since this is a lightning talk, let's lump all that together into one set of people. There's also the set of people who use. Now, this isn't to scale, because we need to keep the text legible. But the interesting thing I think about these Venn diagrams is not the overlaps, it's those little bits that aren't intersections. And this we see as the project grows. We see contributors who have very particular niche interests in some areas of performance, some areas of algorithms and data structures, but they may not really be users of the software. In terms of the users, we also have a bit of a split. We have those who build on it, the application developers. Dian had a great talk about the pain they experienced this morning. And then those who operate the database, those who have to set them up, patch them, all of those sorts of fun things. And there are abstractions that we'll see on both sides of this that we can build or that third parties build to make all of this easier. Then the other view of what community is those who promote, those who feel invested in a particular piece of open source software. Again here, I think the really interesting bit is that exception there at the top. That is our reluctant user community. And it's one of those signs of Postgres' maturity, one of those signs of Postgres' progress, that this community exists. And there are people who are using Postgres because of other decisions they've made. So maybe they're using some software that requires Postgres, GitLab, for instance. We see big corporate change initiatives, people who are pushing Postgres in to displace other databases. That was the big thing I saw when I was in pre-sales. Or people who are adopting Postgres for certain of its benefits, but then they're taking all the pain of the change. And this is a community which I think we don't work with very well at the moment. We're certainly not going to see them in a room like this. Because this is a room full of that yellow circle of the people who care about and feel invested in the project. So what can we do to help this group? Firstly, there's just a lot of content required. Explainers, migration guides, but I think quite important, there are two things that are quite important about this. Firstly, not to write them in terms of comparison, but to write them in terms of analogies. We need to know that people think about things in certain ways. Often from the first database engine they use, they'll think about things using SQL Server's words, Oracle's words. And obviously those things don't map completely clearly. The other one, which we have seen some unfortunate noise about, is having deep expertise on both sides of the story. There have been some quite famous comparison articles where it's very clear that people really knew their Postgres and didn't know the thing they were comparing to. Abstractions are also important. The cloud providers provide a lot of this in terms of people just getting a Postgres. On-prem, I think the Kubernetes efforts are going quite well for that. Database as a service, ideally sort of multiple database as a service stuff. And then abstractions for developers, we've heard about those a bit as well, and not as a Postgres community as a whole, as a project as a whole, but as individuals, there's opportunity for us to get involved there in making some of those things better, making them understand Postgres better. Thank you very much.
Thank you very much, but I was foiled again. Right, so huge apologies to the previous speaker for the incorrect introduction because we were missing one of the sets of slides. So I just wanted to. It was your slides that we were missing. I am so sorry. You didn't send me that I was speaking. Oh. Okay, I apologize. We will talk about it afterwards. I have made a big mistake and I am very sorry. I think we might have missed an email. Oh, because I didn't know I was going to speak. Oh, I'm so sorry.
Surprise, you're on the spot.
Well, if you have your talk ready and you would like to give it, then we will absolutely welcome you to the stage to give your talk.
Okay, thank you. Yeah, this is totally going to be improv because I wanted to speak, but I didn't get the email, so I didn't know I was going to speak today. And I was going to be talking about using Postgres for machine learning. Currently, I'm a predictive analytics student, and I've done a couple of ETL, that's extract, transform, and load with Postgres. And usually when you want to train a model, you would have to source data from different places. It could be like from other DBs or from other applications, or maybe even it could be hardware, like a hard copy. You maybe turn them into soft copy, and then you convert them into something readable, maybe like a JSON or a text or something like that. So typically you want a scalable database, and in this instance, that's going to be a Postgres database. And I've had to use the Postgres for a couple of these data preparation. So typically what we would do is when you source this data from different sources, you transfer, maybe you can write a script. Typically you write a script and you get this data into your DB, and then you want to prepare your data in different ways. For example, there could be outliers, there could be missing values, depending on what you want to train your data for. You have to make all these queries to find missing values, outliers. Sometimes outliers don't mean that the data is bad. It could also mean, let's say, you're trying to train for, let's say, salary range, for example, and let's say there's an outlier for, one person or a couple of people, then you don't want to remove this outlier because it could make your model be biased. So you want to do all these processes with your Postgres database, and it has proven to be very useful. So if you're thinking of a good DB for your machine learning data processing, then Postgres is an ideal database for you. Thank you.
Absolutely amazing. I think that deserves an extra round of applause and a cheer for doing an improvised lightning talk.